Hi everyone. Today's lesson is recognizing and extending geometric sequences. So lesson 105. What is a geometric sequence? A geometric sequence is a sequence of numbers where you have a constant ratio between consecutive terms. So between each term, to go from one term to the next, you need to multiply by the same number. And that number that you're going to be multiplying by is called the common ratio. So how do you find the common ratio? You find it by taking the first term and dividing it by its previous term. So if I have in this example here 3, 6, 12, and 24, to find the common ratio, you take the second term and you divide it by the first one. So 6 divided by 3 is 2, and you go to the next two. 12 divided by 6 is 2, and the next two, 24 divided by 12 is also 2. So they should all have the same common ratio for it to be a geometric sequence. So let's take an example, look at it, one of these examples. I have 320, negative 80, 20, and negative 5. So I'm going to try to find the common ratio. So I start with the second term, a negative 80. I need to divide it by the first term, which is 320. I can divide an 80 out in the numerator. That gives me a negative 1. Divide an 80 in the denominator, and that gives me 4. The next one, the next two terms, I have 20 divided by a negative 80. I can divide a 20 out in the numerator. That gives me a 1. Divide 20 in the denominator gets me a negative 4. So I can see that my common ratio is a negative 1/4. The next example, the one in the gray box, we have 0.4, 1, 2.5, and then 6.25. You can keep them as decimals here, or you can change them as fractions to help you figure out what the common ratio would be. I'm going to use them in fractions. So 0.4 is like the same thing as saying 2/5. Now I take the second term, so I have 1 over 1. Now I need to divide by 2/5, which would be the reciprocal of the fraction 5/2. 1 times 5/2 is 5/2, or 2.5. Now if I take the next two terms, 2.5, so if I take 2.5 and I divide that by 1, I get 2.5. So my common ratio in this example would be 2.5. So I'm multiplying by 2.5 every time. We'll do one more and then you can do the next two yourself. So I have 2, 16, 128, and 1024. So I take the first two terms, I take the second, divided by the first. So 16 divided by 2 gives you 8. The next two, 128 divided by 16, also gives me 8. So the common ratio here is 8. Now you may do the next two yourself if you need extra practice. Example 2a, extending the geometric sequences. So here they give us the start of the sequence. We need to find the next 4 terms. And so in order to do this, we need to find the common ratio first. So let's look at the very first one. 250 to negative 50. How do we go from 250 to a negative 50? Well, if I take the second term, negative 50, divided by 250, I can divide a 50 out of both the numerator and the denominator. Negative 50 divided by 50 is a negative 1. 250 divided by 50 is a positive 5. So I have a negative 1/5. So really, I'm dividing by a negative 5 each time. So a negative 2 divided by a negative 1/5 is a positive 2/5. And I take my next term, so a 2/5, I multiply that by a negative 1/5. That will give me a negative 2 over 25. So I'll write that down. And then I have to multiply that by another negative 1/5. Negative 2/25 times a negative 1/5 is a positive 2 over 125. And then I have to multiply a positive 2 over 125 times a negative 1/5. And that will give me an answer of a negative 2 over 625. That would complete the geometric sequence. The next example, 5, negative 15, 45, negative 135. If I take the first two terms, negative 15 divided by 5, that gives me a negative 3. So I'm going to be multiplying everything by a negative 3. So to make this go a little bit quicker, we'll use our calculator here. So I get my calculator out. I have a negative 3 times a negative 135. That will give us an answer of 405. So I'm going to put 405 here. Then I take that 405 and I multiply that by a negative 3 again. When I do that, you get negative 1215. And then I take the negative 1,215, multiply it by a negative 3, and that gives us 3,645. 3,645. Then I take that same number, 3,645, and I multiply that by a negative 3, and you get a negative 10,935. So a negative 10,935. And that completes the sequence. You may do the next one yourself for extra practice. Example 3, find the nth term of a geometric sequence. So here we're going to be using a formula that you can use to find any term of a geometric sequence. So first we need to know, what does the n stand for? What does the lowercase a stand for? What does the r stand for? Well, the lowercase a, stands for the first term. The r stands for the common ratio. And then the n means which term are you finding. So if you're trying to find the sixth term, as in this example, I'm trying to find the sixth term. I have to put a number 6 wherever I see an n. So they put a 6 here. So I'm trying to find the sixth term, and they put a 6 here. And then they use the formula to find the sixth term. So the first term was 7. The common ratio is negative 3. And if you're finding the sixth term, it's 6 minus 1, which is 5. So I raise negative 3 to the 5th power, then multiply it by 7 to get my answer. And that's how they got negative 1,701. So let's take an example, look at the next example. Find the seventh term, 1/3, negative 1/9, 1 over 27. So I need to use my formula. I need to find the seventh term, and the first term is 1/3, and I need to find the common ratio. To go from 1/3 to a negative 1/9, I'm going to start with a negative 1/9. I need to divide by the first term. Since the first term is a fraction, I'm going to multiply by the reciprocal, 3 over 1. This will give you a negative 1/3. So that would be my common ratio, negative 1/3. And since 7 goes in for n, I'm finding the n term, I have 7 minus 1, which will really be the sixth term. So I need to rewrite our formula. Would be, to find the sixth term, it would be 1/3 times a negative 1/3 to the 6th power. So when I do that, I'll get my calculator out again. So now I clear what I had before. I have to raise both the numerator and the denominator to the sixth term. So -1 to the sixth term is 1. 3 to the sixth power is 729. So now I have 1 over 729. Now I need to multiply that by 1/3. So I need to multiply 729 by 3. That will give me 2,187. So now I have 1 over 2,187 would be my seventh term in this example. Let's look at the next one. Find the nth term. The nth term, so I need to find the ninth term. So I'm going to put a 9 for n. My first term is 17. I need to multiply it by the common ratio. So to go from 17 to 8.5. Well, 8.5 is half of 17. So I'm really going to be multiplying 17 by half. So this is going to be my common ratio. And since I'm finding the ninth term, 9 minus 1 gives me 8. So I'm really finding the eighth term times the first term. Let's get our calculator back out. And I have 2 to the 8th power gives us 256. So that's going to be our denominator. So I have 17 times 1 over 256. When I multiply those together, you get 17 over 256. This would be our ninth term of that sequence. I'm going to have you work on these next two yourself. And example 4a, application. A ball is dropped from a height of 2 yards. The height of each bounce is 85% of the previous height. What is the height of the ball after 10 bounces? So right now, the ball drops from a height of 2 yards. Then it bounces up. So this is the first bounce. And it goes up a certain height. It's 85% of the original height. So if we go to our calculator and we find out what is 85% of 2 yards. So 2 times 0.85 would be 1.7. So 1.7 is 85% of 2 yards. So my first term is actually 1.7. So if I use my formula, I need to find the 10th term. When the first term is 1.7, I need to find the common ratio. The common ratio is 85% of the previous height. So I'm going to take 0.85. So it's a percent, so it's going to be that decimal 0.85. And I have 10 minus 1. So I'm trying to find the next 9 terms. Now if I use my calculator here, we're going to have 1.7 times parentheses 0.85 and parentheses, actually put that wrong, 0.85 and parentheses. Raise that to the 9th term, you would get an answer of 0.39374 and so on. They want us to round your answer. We should round our answer. Usually you should round it to the nearest hundredth. So if we were rounded to 2 decimal places, that would be 0.39. Would be our 10th after bounce. So 0.39 yards. This Next example, we have a fish tank is 9/10 full. Every minute, 1/3 of the water leaks out of the tank. After 5 minutes, how full is the tank? Now, this one's a little tricky because they're telling you that it's 9/10 full, but they're telling you how much is going out of the tank. So we need to know how much water is staying in the tank. If 1/3 is leaving out, that leaves 2/3 of the water staying in. So if you already had 9/10 of the water of the tank filled, 2/3 of it stays in. We need to multiply 9/10 times 2/3. And I can do some simplifying here. I can divide a 2 out here, divide a 2 out here, divide a 3 down here, divide a 3 in the numerator. That gives us 3/5. So after 1 minute, you have 3/5 of the water left in the tank. So that's our first term. So I'm trying to find the fifth term. So after 5 minutes. So the first term is 3/5. I need to know what the common ratio is. And since you're losing 1/3 every time, the common ratio, you are actually how much water is still left in there is 2/3. And I need to raise that to the 5th minus 1 power. And so when I go about solving this, 2 to the 5th power, we can get our calculator back out. 2 to the 5th power would be 32. So right now I have 3/5 times 32 over, and then 3 to the 5th power, 3 to the 5th power, or to the 4th power, be 81. I made a mistake on this one. It shouldn't have been 2 to the 5th power. It should be 2 to the 4th power, which would give you 16. So 2 to the 4th power would be 16. Now I just multiply straight across. But before I do that, I can do some simplifying. I can simplify 3 and 81. Take a 1 out, that gives me 17. Not 17, 27. And then we multiply straight across, so we have 16 over 5 times 27 is 135. So after 5 minutes, your tank would be 16 over 1/35 amount left. Your assignment for next time is 1 through 4, 6 through 7, 9, 13, 18, and 22.